that. Right. Okay. Well, welcome everyone, and I hope you've all had an excellent time away from the Agrarians workplace and platform and all of that, although some of you, of course, have not. I've seen there's been quite a lot of material coming across and questions and whatnot over the break. But yeah, really appreciate you all doing that, and I hope you had a wonderful Christmas or festive season, whatever you choose to celebrate, a new year. Okay, so this week is about access. It's also, of course, about reconnecting and having us all catch up. I know a lot of you have been doing that over the break, so appreciate you doing all you can there to do that. And of course, we've got the rest of the program to do that as well. But this week we're going to talk about access, which is the fourth layer on the Agrarians platform, or farm roads and the keyline scale of permanence. So let's get straight into it. Hang on, what's going on there? There we go. So the primary texts for this, apart from climate, but really primary texts for this topic, because there aren't many books. Well, I can't think of really any books that I can recommend on farm roads and farm road design in particular. There's very little material out there altogether. We're working on that naturally, but what we've got here is geography, which helps us to, well, at least frame where roads will go into a system, and then looking at water and how the lines of water will interact with the roads that we may well put in. And of course, now we're working on the latest piece, which is the access chapter, which is thanks to all of those who've contributed donations. And I know some of you are on the call today to the Agrarians Handbook project, where Georgie's and Andrew are now able to work full time on that for the next, at least the next 4 months, thanks to the donations that we've been able to receive. So that'll get this access chapter done, which we've already done. We've got a very large 500-page manuscript, which I'm whittling down from the original. So that should be out in the next month or so. So yeah, looking forward to that. Andrew's already done a fair bit of work on it. So when we look at roads, as it says here in this triptych, we're looking at roads, tracks, lanes, trails, whatever the case. They're all fairly long-lived or long-lasting features in landscapes. And when we create them, we tend to stick to them. There is a phenomena, and I forget the name of it now, in landscape architecture, a practice, you might say. And I first heard about it in years ago. It was at Monash University, when Monash University here in Melbourne, Victoria, was being developed. And the landscape architects decided to not put down the majority of the footpaths for the students and staff at the university. They decided to make the university, all the new buildings, etc., and then all of the main roads that came in, of course, the paved roads, and then they basically opened the university and let the students walk wherever they wanted to. And by doing that, they then were able to determine by that foot traffic and by the marks, by the trails that were left behind, what were the best lines to put the paving down on, because the students' footpaths basically told them. So that's an interesting aside, I think so. An interesting aside in the way that one can look at road placement or trail placement. But if we were to follow that through, then we may well build roads following cow tracks and following sheep tracks, or animal tracks that we would have in the landscape as well. And when one questions that, as I did recently, I was on a project and I followed it. I was doing some survey work and I followed some cow tracks, and the mere presence of a cow track tells me about the management of that landscape. It tells me that it's a set stocked landscape, that there's no there's no short-term rotational or planned grazing process in place, because if there were, then there wouldn't be a trail in the first place. And what is the trail doing? Well, the trail's going from primary grazing areas or lounging areas to a water supply. And what was the alignment of that track? Well, the alignment of the track was usually the path of least resistance. Animals are not stupid, and if you're a cow, you're a very heavy animal to walk around, so you're going to use the least amount of energy you can to get from A to B. So one tends to see a sort of a low energy beeline, if you like. And that beeline might actually, and often does, follow what's called a contour alignment. And that's what we see on the screen here. We see two different kinds of roads in place. We see the ones that are going across the screen, and whilst they're not on contour, they follow a contour gradient or a contour alignment. And that's one kind of road that we will typically build into a landscape or design into a landscape. And the other type is this one that just goes up the screen here, which is a ridge alignment. It's a bit awkwardly drawn here, but that's the other kind of alignment that we will follow, is a ridge alignment. So a lot of the trails that we'll see animals create will often be on a contour alignment, because it uses the least amount of energy to walk along that. But when we need to, the other kind of road that we will often build is one that follows a ridge alignment. And this is not unusual in ordinary road design as well. Suburban road design is one example, however, of where an additional alignment is placed, and that's one where you've got a gully alignment. And so if there's a primary valley in a system, then often, because of the way that conventional subdivision designers or engineers are looking to exhaust water from the subdivision, they'll often put stormwater pipelines at the base of a primary valley, and then have road infrastructure go over the top of that. That will also stormwater infrastructure, and also effluent disposal infrastructure will go down those lines. And of course, that undermines completely the capacity to store any water in the landscape, as one would in a more of a keyline flavour. So that's something that hasn't generally happened too much, and we'll explore some of that as we go along. So this is from the access chapter of the Agrarian's Handbook, and here's for those of you who've been reading through the Agrarian's Handbook, you'd see that we've got these sample landscapes that we're using, and this is one example of that sample landscape in practice, where we're showing various points of interest. And so those points of interest are places where there may be particular things to consider as far as a road is concerned. There might be points where there might naturally be an intersection. There might be other points of interest that one would survey in as being of interest to you, be it geological in the surveys. There might be rock piles. It could be all sorts of different things that are going on there that will cause you to mark a point of interest as such. Crossing locations, and that's where we've got a crossing or a culvert that might have to be placed, or indeed a pond might have to be built there, as I'll talk about later. But what it shows here also is really the possible routes that are best aligned. And so you can see in this landscape, there's this sort of peripheral road which really follows what which looks like primarily a main ridge line. So you've got that, and often what one will find in the landscape anyway is that a lot of road building that happens is following a ridge alignment, especially large roads, and also a lot of country roads. Forestry trails, etc., often following that alignment. The other alignment that's often followed is this alignment here, which is called a contour alignment. And then we combine those sometimes. So you can see here, there's a primary ridge coming down this slope, and then that joins up with a road which is on a contour alignment. And when I say a contour alignment, I must stress that it's not on contour. It's a road which has a gradient, but it follows an alignment which is parallel with the contours of the landscape, but is not on contour. So we'll talk further about that and why one wouldn't do that later. So that just gives you an example of how one might, in a given landscape, look to place roads into a landscape for best access. Now, the other question that arises is, what's the access for? You know, what are you trying to access? And then other questions that go on from that are around, well, if you're going to build that road, what weight of machinery is going to be on that? What turning radiuses do they have? All of those sorts of things. So they're all questions for you. What regularity of use that you would have, etc. Asking those sorts of questions are useful because then they'll inform you as to how well that road needs to be built and what slope it might go on, because some roads might be on slopes that, for the particular kinds of vehicles which are regularly going to use them, it might be too great a slope, and so therefore is going to have some problems. If you've got crossings, you know, that's particularly an issue when you're looking at ridge roads. You might find that just in this little spot, so that's a nice little ridge to go up and down, but you know, you might look at this spot here and go, well, what's the slope there? If I try and bring a vehicle up there, say I've got a house site which is up around here, which a lot of people will have, that might be difficult to get to without this actually being paved, and it may actually exceed the slope that's allowable by the municipality, especially in a lot of areas where fire safety vehicles or fire service vehicles require access as a condition of gaining a permit or approval. And as a result, you may need to change the route of this road you might need to actually create a switchback, which is another alignment. Still following somewhat of a ridge alignment, but you might need to have some sort of switchback to accommodate the reality that this slope here is too great to just go straight up. So there's those sorts of things which add to the pie of considerations, as there always are. So that's what we've got there. Now, sort of look at this in practice. Well, as we talked about before, there's this handscape concept that we use all of the time, where you can look at the position of roads on your own handscape. If you're especially for those of you who are still having trouble looking at a landscape in 3D. So about my hair, I've been at the beach for the last week, and I've very much got stiff, salty hair. So yeah, so pardon me for the shock there. So once we've got a map, what we're looking at here is, just as you can see from this last diagram, you know, you've created this map. What about creating now some lines on it? And now you perhaps start to see why before the break, why we went through the process of asking you in your task work to do in your keyline geography, why we asked you to go and mark all of the ridges of the landscape. Well, part of that, the big part of the reason for that is so that you can understand. Sorry, I just thought I saw something. come through, sorry. So that you can have the map tell you, have the landscape tell you where to put things. And as I think I've said before, I find that quite liberating when one does that, because it means that the decision making about, which is often difficult, the decision making about where to put things is actually that decision is largely made for you by you just following these particular alignments. Now, like I just talked about, you may need to amend that because of slope considerations. You may also need to amend it because you might go along one of these ridge lines and find that there's a huge big rock right in the middle of there. Well, you're going to have to go around it, you know. So there's going to be those practical things that you need to consider. But it is a good way to start your decision making about the patterning of roads and a landscape. Now, part of that is defined, for example, in the application of the Regrarians platform by looking at this particular diagram. I might just shift out of here for just one moment. Bear with me. About this before. Hang on. Can I escape? Yes, I can. So if I go to the Regrarians webpage, and we'll just go to services and farm planning. This is an old example. Georgie's updating this. So what we've got here is topographic maps. So these are 5 metre contours. This is of a property in South Australia we designed years ago. Excuse me. So here we have the topographic layer. We've then, onto that, pinpointed some of the highest dam locations. So thinking about the water layer, we've applied the water layer to this particular site, and that's given us these 2 positions for prospective dams that we might want to build. Then we want to harvest water that will fill those dams. So we're going to do that off this main ridge line that we've got through here. And then calculate the dam catchment areas. And, you know, this is stuff that a number of you have already done. Then we've actually, from that, placed the irrigation reticulation system. Now, when one looks at that, you can see that broadly that we're following a ridge alignment to do that. But then there's a couple of spots, like along here, where we followed a contour alignment as well. But by and large, the layout of this system is a ridge alignment. Now, why have we done that? Because when one sets up, and this is part of what will come to you as you put these layers together, if you follow our kind of approach. When you have water reticulated in a landscape following these parameters, these keyline parameters, and I'll just put a little caveat in there. P.A. Yeomans was just entering the era when plastic pipe started to become very, very commonly used in agricultural land development. And so a lot of his designs, well, I haven't seen barely any reference to the positioning of pipe in a polypipe world, which is completely different to the pipeline systems that he was working, which were, you know, jointed aluminium pipes or aluminum pipes and whatnot, which didn't have anywhere near the flexibility of position to what we have here. Also, in P.A. Yeoman's time, the primary source for livestock water were actually ponds themselves, and so you'll notice in a lot of diagrams of Yeoman's or photos of Yeoman's properties, there was no fences, you know, around. There were no fences placed around dams to exclude livestock access, which is something, of course, that we do as best practice today. So, putting that into context and considering still the patterns that Yeoman's sort of exposed to us in the placement of things, we will generally put our and I've talked about this before, but we'll generally put our pipeline layout following a ridge alignment in most of these pastoral landscapes. And the reason for that is that it keeps water high in the landscape. So you've always got water coming high in the landscape. Now, the other part of it, of course, is that if you have water high in the landscape, then when animals come to drink out of troughs, well, then, of course, they're always going up to the trough to drink. And when they do that, they help us with anandromous drainage practice, which is where there's a lot of, if you look at this, any landscape, water always carries nutrient with it. And so typically, you'll typically find that that most nutrient and the most nutritious of grasses, etc., are to be found in the valleys, because gravity moves those nutrients there, and then the soils accumulate those nutrients and produce more luxuriant grasses or forage, which is then consumed by the animals. Now, let's assume that you were to put a trough in the middle here in this valley, which a lot of people may well do. Well, then there's no movement of those nutrients up and down the slope. Peter Andrews of Natural Sequence Farming talks about this a lot too. So it's certainly not an exclusive conversation we're having here. He will talk about not so much troughs, but feeding up on ridges. So if you're doing any feeding with any straw or with any hay, that you will do that up on the ridges, because what happens then is that animals will then come up to the top of the slope, and be fed from, and then they will bring their nutrient and their excrement up to the top of the slope, which then washes down with rain back down the slope. So you've got that really effective movement of nutrient up and down the slope. So we can enhance that. Now, of course, in this overlapping that we have with the positioning of all of these elements, of roads and water supply lines and everything, what you can start to see, and this is where the next slide will show it, is that the position of all of the access lines actually follows exactly the position of the water lines. So that's something that's pretty common for us to do. Now I'll move along to where we get to the position of fencing and whatnot. Well, you can't quite see that here, but the position of all of the fences in this landscape are also following those lines. So once one sets up the water lines and the access lines, well, then ostensibly that frames what will become your paddock design. Now you can see here on this property, it's got quite rectilinear. There's fence along here, another one here. There's another one along here, and so on. So it's following sort of A to B lines, because there's no other layers of consideration, perhaps except for soil type, that have been considered in the positioning of the fence. So, of course, and this is a good illustration of that when we look at things through the keyline lens or the Regarians platform lens, then that puts all of that to one side. And when one thinks about it, there's certainly some value. If we go back to the discussion on landscape capability or land capability, there's certainly scope for consideration of positioning fences according to landscape capability, which is in part what's been done here. We've got a valley down the bottom here, or a river flat, and so there was a fence line along there to accommodate the fact that this floods out from time to time, and that this has a different capability as a landscape as a result. Now, that positions that fence, but how can, so I suppose the dance that we're looking at here is how that we try and consider landscape capability in the positioning of roads, because and then how that's going to affect the shape of paddocks. So if you look at this situation here, I've responded to that by, yes, going and putting a road that follows this ridge all the way down, and then has a rising gradient up the slope here to this ridge. Now, on a contour alignment. And then you can see here, this particular system where I've got these widely spaced rows of north-south trees, that ostensibly becomes the new paddock, whereas before it was just this little rectangle that followed the edge of the river. So we've adjusted things up a bit to accommodate the higher level considerations of position of access and water lines in this landscape. Right, well, that's probably enough on that. Let's go back to here. Oops, what happened there? View, I think it was dismiss. Yes, sorry, I just pushed the wrong button. View, present, that's the one. So this is another example here on the screen of, what these arrows are doing, of a project that a lot of you will be familiar with by now because I've used it as an example quite a lot, McIver Farm. And what we've done here is we've done a very quick, concept plan. It took just a couple of hours, this one. So I've done what I've suggested to you all, which is to do your contour mapping and then get your, place all of your ridges on it. All right, see you later, Joe. Nice to see you, mate. Take care. Place all of your ridges on the system, on the map, and then, as we've done here, is to try and link up some of those ridges by some of these contour alignment roads. Now, you'll notice that we've done a bit of that, and then you'll notice over here on the right-hand screen where we've actually done the work, and you'll notice that there's a few roads that are actually missing. Now, why is that? Well, because often what will happen in the order of things is that you'll start with a road design which will be very conceptual, and then you'll go out and actually test that to see how that will actually work. And there's a whole parameter of reasons, or whole range of things to consider here. In the case of this particular project, the main consideration was not of the position of the ridge roads, which you can see that we largely retained. In fact, I think in all cases here, we pretty well retained all of the ridge roads that we were looking at. So there was no discussion there. It was more the contour alignment roads that were under question here. Now, what caused us to have questions there? Well, let's look at this one here, for example, where we've got this road coming through. Whoops. Go back. Where we've got this road coming through here, you can see that there's a dam also concepted here. Now, when we come over here and you see there is no dam there. Now, will there be a dam in future? Well, the answer is no, because one of the things, just as we talked about when we looked at building a dam, that there's all of these steps. Oh, excuse me. There's all of these steps involved in building a dam. And one of the and a number of those steps are well before we actually build it, is going and doing the soil testing. Anyway, when we went out and did the soil testing for this particular position to build the dam, we found that we went down to about 6 meters of depth and found nothing but granitic sand. And as a result, we just weren't able to find the material to seal that dam. So we thought, and it wasn't a really critical one in the whole scheme of things. And so we kiboshed that particular dam site. And so we still felt that that was a good access because it was sort of in a middle point. And so we still went through there. But what we did, because this is a wet valley, what we did was we put a culvert there so that we could get across that valley in wet conditions. So we did that. Now, similarly, down here, you'll see that there was another dam looking to be positioned here. It was the same deal. It wasn't until down here that this landscape actually had enough clay to build the dam, which is largely in a valley, which is largely, that water is very reliable once it gets down to there, of course. But it had lost its energy. Now this dam up the top here was a different question. It was marginal in terms of material, but we had a source of material right close by, so we enlarged this dam here, which allowed us to put this particular dam in. And as a result of doing that, we were able to have a storage of quite a few million litres of water of storage right at the top of the landscape, which you can see here is at around the 360 metre level, and the bottom of the property is at 310. So we've got quite a lot of gravity of fall from this particular storage. So that's the kind of thing that we changed up a bit there, and you'll see there's also another one that we didn't build in here because there was already an existing road here which actually works in okay with what we're doing. And you'll see that on the next map quite well. So the other parameter to consider with road placement, especially like if you look at it, that a lot of you, especially those of you who are doing grazing properties, you'll be concentrating on the following layers. You'll be concentrating on the water layer, because what you're looking at is trying to set up water systems to reticulate a supply of water around for your livestock. Number two is that you'll be interested in access, because you want to gain all-weather access across the property. Number three, the other layer that you're usually primarily concerned with is the fencing layer. And so when we're considering the position of roads and the frequency of roads, particularly contour gradient roads, what we're considering then is a fencing factor. And that fencing factor that comes in with most consideration is how much wire you can carry on a reel. Because for a lot of you, you'll be shifting to more frequent moves of your livestock. And so as a result, one of the primary tools that you'll be using is the electric fence reel with tread-in posts, temporary posts. And so this very temporary apparatus will actually help you to define how widely apart your roads will be, because your roads tend to frame, your position of your roads in this process at least, they tend to frame what your paddock areas will be. Because you will typically, when you do this, you'll typically put inside of this, you'll have water supply in there along all of these roads, but then you'll typically put a fence on either side of those, and so that area in between becomes a paddock. And so one will then look at, well, what's the distance between here and here? Well, that distance in this case will be about 300 to 400 metres, because if I'm going to graze up and down this slope, for example, well, then I'm going to need to connect it to another permanent. So I'm going to hook onto this permanent fence and that permanent fence, and I'm going to run that reel out. And that's how I might do that. Now, let's assume that that's actually 600 metres from here to here. Well, that would probably mean that we better be putting another access in here, or or another fence line in here, so that we can split that in half. And you might just run along there with the quad. Now, where's the position of water going to be in that case? Well, you probably need, you won't, if you would still only need to have a water line here. Would you go and put another water line here if that was the case? You would consider it, but given you've already got a water line along here, you may look at it and go, well, that's just not economic for me. So you're going to have to make a justification for that. It may be, though, that the diameter, and this is all part of the continuous complexity that's involved in farm planning, is that one of the decisions you'd make here is, well, let's say I've got a 2-inch line that's running along here, or a 50 mil line, which is my main supply line. I might look at this and split this in half and put across there an 1.5 inch line or an 1.25 inch line, because I've determined that that's all I need for the number of animals that are going to be running in that system, in that area. And so if that's the case, then go for it. Now, that's going to naturally be a much cheaper pipeline than it would be if you were to just go and put 2 inch across there. In any case, you can build these things and you can just have your water supply along here, which will be at the bottom of that slope. You can then play that out for a year or two and see how it works on the ground. And if it doesn't work on the ground and you've got a bit of cash to spare, or you just see that it's going to be that much more advantage, well, then you go, gee, I'm going to, with this permanent fence that I've got across here, I'm going to bang another pipeline in. So that I've always got, and ditto along here, if you're going to split this in half, you'd put another pipeline along there, for example. So you play these things out. Okay. So now, interestingly, this was don't think I've had this happen before. Anyway, I did a design, as you can see above here. The Hagen family just had one half, or my clients only had one half of this property. There's a fence line that was along here. Along here. That split the property in two between two brothers. Anyway, one brother sold the other property to the other brother, and so he was able to get the square. And so there's the old fence line along there. Now, I'd designed this side previously, which is what we were looking at just before, flipped around the other way, and I designed it not considering that at some stage that we were going to annex this property next door as well. Now, it posed some interesting, I won't say challenges, but it posed some interesting questions, because the challenge of positioning roads in this particular landscape was not that great, because again, I just followed the simple parameters that we've already discussed. There were, however, some existing roads on the property, and so what we did there was we evaluated some of those. Now, an example of that, it's hard, perhaps a bit hard to see. See, there's a road that goes through here. Well, we made a decision based on landscape. There's a ridge line that runs right down the middle here, and that we were going to build this contour alignment because we needed another dam. So we built this dam here, and it just happened to fit with this particular contour alignment here. Now, this road basically from the entrance all the way along here, up the side fence, and then up to here, and then all the way around to here existed. And it had a contour alignment. So it was falling back to here, to this small dam, which they used. It was an existing dam they used to cross over. So they built a crossing over that dam. And then it continued along to here. And then it connected in with this, again, a sort of a contour aligned road, which had a fairly aggressive fall. I'd say about a 1 in 50 fall, so quite aggressive. And then it came and connected up with this boundary road again. Okay. Now, I looked at that and we talked about this a bit, because I said to him, look, can we just do a pure keyline alignment road, and then we'll come back and look at the existing roads that are on the property, and let's see how we can, if they fit. And if they don't, then let's look at what we can do there. So that being the case, what we did was decided that this road was actually going to no longer be necessary. You can see a little short one here. So what we did was we went ahead with doing this one, which already existed from the other plan, We built, and we, instead of having this one, we decided to have it overcome by this one. So what we then did was went along with the bulldozer and covered this road back up with any soil that we had, and then we put the pigs over the top of it, and the pigs the pigs with their feeding, and then we follow that up with because pigs, when they root up the ground, they put a lot of nutrient down, create a pathway of disturbance, and then we run the keyline super plow over it, sow it down to a cover crop, and I expect that within 2 or 3 years, we won't actually see that road. There'll be some small hints of it. That's largely because we filled the road in, as it were, by running the bulldozer over it and pushing the slope, the shoulder of the road up to cover the sort of wound. We'll probably see some parts of it where the cut was quite severe, but in large part, we won't see it at all anymore, and so it will just become a part of the landscape. So where I'm getting to here is that in some cases, and this is another case here, we've got an existing old road that goes along here to service what used to be horse yards, and so now we've got this road running through. We won't need to have that one either. So we did build this in. You can see there's another dam that we've placed in there. So we've built this dam as a crossing, and then that dam overflows and then runs along to here to this dam. This intersection here, it falls from here down to here, so that fills that dam quite well, and in very little rainfall now. So we've done things like that in this particular design to accommodate an existing layout of roads, but then we've evaluated how important they were and what the cost would be in the overall scheme of things as far as this project is concerned. Now, just to give you a little bit of insight, what you see on the screen here is about $250,000 worth of expenditure on about 250 hectares. So we're looking at, this is all of the tree planting, all of the fencing, all of the earthworks. There's a lot of fencing in here. You can see there's little fences in here every 40 metres and so on. So there's a lot of work. So it's cost about $1,000 a hectare, so about $500 an acre to set this pastured pig property up. And it's a property that it produces about 35 to 40 pigs a week. So it's quite a productive system. Now, if we look at that in the context of the returns, we've been able to evaluate that it returns around about $1.1 million per year. So if we do the math on that, if we've got, just do that quickly. There we go. So if we've got $1 million, sorry, $1.1 million divided by 250 hectares, so that's $4,400 a hectare. Now, if we're running at a profitability of, say, around 15% or 20%, which is approximately what's being run here, then we've actually got a pretty good return, and that includes, you know, loan repayments and all of that sort of thing. So this is after tax and after loan repayments, etc. Profit. Then we've actually got a pretty productive system on our hands here, pretty profitable return on investment as far as this particular site is concerned, based on all of that investment. Now, that's the kind of thing that I would like for you to consider when you're looking at the decisions about what to take out, what to keep, etc. Okay, I've just lost my spot there, I think. There we go. Anybody got any questions? Please chime in. Okay, now let's just have a look at roads and their alignment and construction and whatnot. Now, here's two different roads on two different properties. They're both what I'd call a contour alignment. They're both what I call gradient catchment roads. Now, the purpose of these roads is A, to provide access, but you might say A, to provide a reliable catchment of water, if we look at it through the lens of the scale of permanence. So their first purpose is to harvest water reliably into a landscape and have that water delivered to some sort of pond or dam. Their second purpose is to provide an access, an all-weather access. And so that's what we've got here, and that's what they do. Now, they're very effective, these two roads. In both cases, I've found that the clients have come back to me after years of drought, and they've said, well, where we've got those dams are the only ones on the property which have filled up in those years of drought, or have resulted in enough sufficient water for us to not run out of water completely. Now, why is that? Well, when we look at the runoff coefficients of different landscapes, some of the highest, well, if you look at it in the order, the highest runoff coefficients you get off a landscape are off roofs, especially highly impervious roofs such as corrugated iron and other sheet metal. They can give like 95% efficient catchment. So there is therefore 95% of the water that falls as rainfall will run off, be collected by a gutter, and end up in a tank. So they're very, very efficient. And some people are quite surprised when they set up a new tank on a building or an annex or whatever, and the first time it fills off what seems to be a relatively small amount of rainfall. It's one of the values of having rainwater harvesting systems is just that, how effective they are. Now, similarly in the landscape, as we go down the order here, the next most effective landscapes to harvest water off are paved areas. So particularly where you've got concrete paving or bitumen, asphalt paved areas, they're quite resistant to infiltration as well. And as a result, if ever you build those sorts of systems, you find out of quite small rainfall events if you haven't put the drainage in place. Why you should put the drainage in place, you find out fairly quickly. Now, next down from that is roads. If we look at roads which don't have a seal as such, they harvest water reasonably, and a lot of roads, because of their position in landscapes, actually cause a lot of problems because the consideration of rainfall coefficient has not been considered in their placement. So a lot of people who've built roads over the time have just gone from A to B and not really paid much attention to their placement and the implications of that placement from a water perspective. And so again, this is why we go through the order that we go through, and it's why we recommend the due diligence that we do, that you will understand some of that stuff already when you come to the plate. So when it comes to these particular roads, which are both, this one's not quite finished and this one's just finished, you can see it's quite powdery on the surface. These two roads, as they sit right here, are not super efficient harvesters of water, but they will do quite a reasonable job if you get quite good rainfall. Now, there's steps that we will take, but the main thing I want to illustrate before I get to those steps, that I wanted to illustrate as a difference here, is that in the case of, let's move this out of the way a bit. In the case of this particular road, you can see here that there's, that there's this V-shaped gutter here. All right? And then in case of this one, I'll just annotate actually, make it easier. In the case of this one, we've got a road which has a V-shaped gutter, and then it has about a 3% rise up to here, and then you've got the shoulder of the road going off like that. Now in the case of this one, you've got a shoulder which is, it's a lot gentler landscape. It's, I'll just do that again. You've got a shoulder which is coming up quite nicely, like so. It comes all the way to about there, and then it falls down to about here, and then it goes really flat, and then it rises back up again. Now, why is it that we've got these two systems? Well, the reason for that is because we've calculated that these roads are not having, that they have different amounts of water that's actually running along the gutters here. They've got a different catchment which is feeding them. In the case of this particular road, there's this gutter, we've decided, and it gets bigger as it gets along, but we've decided it only needs to be of a particular dimension. So that's the cross section of the road there, if you like. So that's the volume of water that's being carried in there, right? So that little hatched area that I'm just awkwardly filling in here. That's the section. And if you were to go back 1 metre, right, then if that was 1 metre between here and here, based on that section, you could then calculate how many cubic meters, or what value in cubic meters that might be. So it might be 200 litres, or 0.2 of a cubic metre is what we've got there. Now you would calculate going back again based on your peak flow volume, just how much capacity that gutter needs to carry. And so you'll build that out as a result in your spec, right? Now, this particular dam here is quite different. This particular road is quite different. It actually has a dam that is overflowing into it. So this is, from the start, becomes an overflow. And so as a result, we've created this, sorry about my drawing here, but we've created what's called a box gutter as opposed to a V gutter. Now, this box gutter, which goes more along there, I should say, is whatever width it is. It's about, I think it's about 2 metres in width. And it's designed to carry a lot more water, but a lot more gently over a longer distance than this one here is. This one has to carry water for about probably 400 metres from this point. This one, on the other hand, has to carry water for about 1 kilometre. So it's got to carry a lot water, a lot greater distance. So what we're doing here, and this is, look at the permaculture principles here, we're making each element perform multiple functions here. So this is a road system, but it's also an overflow. And so we've got to design it with those parameters in mind, and we have done so very successfully. So again, put all of the things in front of you as far as what information you need, and then you can get these possibilities. Now, the other thing that happens, of course, is that this being the shoulder of the road along here means that this is a really reliable catchment going this way. So water runs across the slope and then comes in and joins up with the water that's already coming down if we get an overflow event from that particular dam there. So you've got all of this water all the way along this road surface, which is following the path of least resistance, which is completely perpendicular to the contour of the road. So water runs at 90 degrees to the contour. And so that water is running really, really short distance across here. So what have we done there for? Same here. The water here is running in that direction. Well, what we've done is we've brought water under control. Now, a lot of cases, what people do when they build roads is that roads are not, that the water is not under control. And you end up having water running down gutters and making gutters and making, you know, where you've got your wheel tracks, the water runs along there, or it just seems to meander all over the place because of the shape of the road that you've created or managed or unmanaged, and so on. So again, go out and pay attention to the roads that are around you and look at the markers of where water has interacted with them, and then you'll start to see whether that road has water under control or not. And that's part of what you will then need to look at remedying or providing some remedy to, and evaluating its cost effectiveness. So that's some of the considerations there. What happened there? Ignore. Okay. Now, there's a Q&A question, a couple of Q&A questions, which I'll get to now. Can I see them? Why aren't they showing up? I think because I've got this. Just bear with me. I'll just clear this drawing. Clear all drawings. Okay. Oh, there we go. Pardon me. All right. Thanks, Ben. Sorry, I couldn't see the roads and see the Q&A, see the presentation and the Q&A at the same time. So if people actually, it might make it a bit easier if you just put things in the chat, because I've got the iPad open and I can see the chat in the iPad, if that's okay. So good morning, Ben. Gradient catchment roads. The gutter is on the uphill side and the dam is on the downhill side, so the water needs to cross. Yeah, I'll show you that in a moment. I'm about to get to that. Thinking of your property in Bendigo and silt and all of that sort of thing. Yeah, no worries. I'll get to that. Thank you. Any reason to slope the road completely downslope? Absolutely, Tom. Good morning to you. Yeah, there is, particularly if you're not looking to harvest any water, and particularly if you've got a contour alignment, and this is where we're doing contour alignment roads, where you're looking to have that water, well, where you've got a slope that's not so great, that being downslope is going to present you with any issues as far as stability is concerned, well, safety is concerned, I should say. So I'll get to that in a moment when I look at some more roads as we go along. How are we going for time? That was halfway good. So let's have a look at some of those questions in place. So yeah, so if anyone's got any questions, just put them in the chat. Don't put them in the Q&A in this case, please, and then I can keep the screen as big as I can on this tiny little 13-inch that I'm working on this morning. Now, oh, come on. So on this particular diagram here, what I'm showing is, the same. Should we go back one? I'll do that. So this position that we've got right here is about where this arrow is. Right now, you can see there's an old road here, which basically goes up the ridge and then down the ridge again. It doesn't follow a ridge line because the actual ridge line here runs through here down to the river. And then there's another ridge line that runs down here somewhere. So, and then there's a valley here, and then there's another valley here. So this dam here, there's the fence line right there, the property boundary. And then this old dam that was built here was not built respecting the property boundary. Excuse me. And as a result, as a legacy of that, it's on both properties. Anyway, when we came to the property to design it, the overflow basically went straight down here and went to nothing and just caused some erosion on the next neighbour's property. So I said to the client, well, how about we take the overflow and use that and bring it back into this dam here. So anyway, so we ran that all the way along. We decided on a gradient that was 1 in 300. So that means that for every 300 units of length, it has 1 unit of fall. So in this case, it's 1 metre of fall for every 300 metres of length. And so with the contour map that we had, which was a good one produced by a drone, we were able to pinpoint this road in and then survey it into the landscape. And it worked quite nicely. Now, the question that we just had there from Ben was, well, what do you do with the silt, etc.? Right, and what do you do with the crossings? Now, this is where what happens sometimes with clients is they don't listen to everything that you said. So they listened to everything that I said here, but they didn't listen on the detail here. So what they ended up doing was right here, slowing this down a bit, and water goes through a pipe here and then goes down and flows over this slope here. Now, in any dam that you build, the steepest part of the dam is right here. And so it's typically not a spot that one would like to have water discharged to, because you'll generally get some erosion down there. Now, that's not the case in this particular case for a variety of circumstances, mainly because of luck. They were able to get a good amount of grass cover here before the dam filled, and before they got any major rainfall events, which caused water to run down and cause any erosion here. But generally, that's not the way I like to do it. The way that I prefer to do it, which is how Yeomans laid this out as well, was that one would actually have the water continue to run, around to the back of the dam. And so therefore, once it got to here, then the water would run over a slope of grass and into the dam that way. And that's one of the gentler parts of the valley, is at the back of the valley, not here at the side here, which is quite steep. So that's not the way I would prefer it to happen. So anyway, in peak flows, what will happen here, and this is what has happened, is that 40 centimetre diameter pipe, or those two pipes, do not have the capacity to be able to take that water. And so what does water do? It banks up and then it runs out over this slope. Now, they could have sorted that out straight from the get-go by just following my advice and having the water here, and then they wouldn't have even needed that pipe, to be quite honest. So, so there was a bit of that happens. But of course, when you do all of this, you'll do everything to the letter of suggestion and due diligence, and you won't have these issues. Now, mouse. Next. Why won't you? Hang on, just one moment. Clear. Mouse. Next slide. Right. Now, I'll deal with that question a bit more as we go along, but it is a good one. Now, the other thing to consider is that, and I spoke about this before, or referred to these types of roads before, is where you're doing a cross-section. And that is, thanks, Jason. I don't know what you were hearing too. That when you do a crossing, there's a few choices that are made to you. Now, ordinarily, one would put, well, the usual practice when one crosses a wet valley, if there's no dam involved, is to put to put the right size culvert pipe in, and then you build up the road over that culvert pipe. Now, I went through a process in this particular case on this property in about 2003, I think it was, where we were building a new road system on this property, and in another particular valley on this property, I was looking at doing the usual thing of putting in some pipes, which I'd done, many, many times before. Now, in this case, I looked at it and I went, how about if we actually build a dam there? Now, I said to the client, who is a good friend, I said, what do you think about building a dam there? He said, well, we don't really need a dam. And I said, well, how much would it cost? And I had the earth mover there with us. I said, how much would it cost for you to strip off the topsoil, build up a bank, and then cover the embankment back over with topsoil and the bowl of the cut, this sort of area here in the dam? And he said, oh, gee, for that site, I think we'd probably do that in about 2 hours. And I said, okay, so what's the hourly rate of this machine? He said, oh, it's about 150 an hour. I said, oh, right, so about $300. I said, all right, well, let's look at that compared to putting some pipes in. I said, how much are the pipes? He said, oh, they're going to be about $300. I said, right, so the pipes alone are about concrete pipes, 40 centimetre diameter. This is from memory. The pipes are going to be about $300, and then we've still got to excavate up to it and so on. And he said, yeah, we've still got to do all of that. Okay, so I said, well, what one piece of infrastructure here is from using the terminology that I think Bill Mollison, the permaculture co-founder, came up with, where you're looking at degenerative infrastructure and regenerative infrastructure. So a road you might classify as a piece of degenerative infrastructure, in that classically it's going to need a lot of maintenance over time, and it's going to degrade over time. It will take a long time to degrade if it's built properly, and that's part of what this whole discussion is about. And it's placed and built properly is one part of it. Designed to be in the right place so it has a high capability of low maintenance is another part of that, which is what we've spent the first hour discussing. Now, when we build a road over a valley and it has a couple of pipes in it, well, that's pretty degenerative infrastructure. How many of you have seen roads over the time, 20, 30, 40 years old, where the pipes have crumbled and, there's all of this infrastructure that decays, and then and what does it produce? All it produces is a crossing. In this case, this photo is 3 years after this pond was created, this crossing was created. Now, interestingly, what's very interesting with this is that being an experiment, we should have made the freeboard of this higher. So the freeboard, which is the differential between the top of the embankment and the full water level, is only about 40 centimetres in this case, 40 or 50 centimetres, and it has slumped. I didn't expect that this would happen. I expected that we'd have an ephemeral water source behind here, that water would stop here, bank up, and then if there was an overflow event, it would overflow through the overflow, which we paved. So we put some crushed rock down there so we could get across. I didn't expect that it would actually become a permanent water source, which it actually has become. And as a result of that, it's saturated this embankment over a much longer period, and we've found ourselves using this road more frequently than we thought we might, which is, again, one of those things that goes back to that Monash University example that I gave at the top of the show. I was saying, well, you build roads, they built roads built paths after people had walked everywhere and left wear marks. Sometimes when you build roads, you don't actually realise how frequently you'll use them until you build them. And then that sort of has you, it has you do engineering in reverse, because now you come back, as I would in this case, and come back to the client and say, actually, we probably need to build this up a bit, because I can see, because what we saw was that because the freeboard wasn't great enough, that we were getting some slumping, and as a result, this road was starting to decay. This is beautiful. This is absolutely amazing. So we're very, very happy with that. Okay. Now, and that's just planted itself as well, which is really interesting. I always find these systems fascinating from that perspective. Okay. Now this is another, so if I go back a couple, so this is this road here, top diagram. So that was 2008 it was built, and we're just, where we took that photo was about here. So, just bear with me. I'll just take a moment. My wife is just texting me and I need to contact her. So just bear with me for 2 shakes, please. Pardon me. So now you can see, if we go back again to here, you can see that we planted this up and we had these rows, this preparation, blah, blah, blah. So, and this is another thing that one will look at, you know, the concept of P.A. Yeoman's concept of the city forest, and particularly if we go back even before that to his concept of the contour strip forest, was that one would have a water conservation channel, which is effectively what this road system is. It's just expanded on, in that the embankment normally of a water conservation channel is actually quite small by comparison to this, where the embankment is quite a lot larger, and it in itself is a catchment surface. So he would have that, and then that would carry water to a dam, and then the dam would have an irrigation channel which would come out the base of it. So you'd have one going in on one gradient and the other going in another gradient. And as they get further, as they come along, they actually get further apart, because this one's falling and this one's falling on the same contour alignment, and so that you end up getting this sort of wedge shape in between the 2 channels. So it's narrow here where the dam is, and then as it comes out, it gets wider and wider apart. And so, yeah, that was a sort of like a no man's land, if you like. And as a result, it became obvious to him that that would be a good place to put trees. And so that's what we've done in this particular case as well. And so there's a good example, one of the best actually, is Ben Falloon down there. This is in 2014 when he's taken this photo. So 6 years after we did, after the previous photo, and he's got a line of Tagesasti along here and a paddock above. And then he's got this line of other trees which are all along here, which are in a strip forest. And so that provides for us now this quite strong division between this paddock here and this really well-established shelter belt, and this road system, which harvests water all the way and goes to this dam at the other end, which you'll see here. So there it runs along there, all the way along, comes along to here, and then goes into this dam. Again, it went into here. It should have. My instruction was for it to not go there, was to go out to the back and then go here. Now, had that been the case, going back to the question before, then if this followed its natural contour, even if we went on contour from here, it would have ended up discharging about here. And so we would have had about 15 to 20 metres of grassed slope for which any sediment that's carried along here would have discharged here, and then and so on. Now, of course, one could, I've done this on another occasion, but I don't have the diagram on here, but one could put some sort of pondage here And so in effect, you would have a cross section where you've got a dam here like that. So there's your dam. And then behind the dam, you've got another depression. And so the water level of the dam may actually go right back to here, but the water discharges off the road into that there first, and then overflows into that. Right. So that's how, in my preferred way of doing things, I would prefer to do it. But look, clients don't follow every letter of my direction, and so we get what we get. Now, another point I would make on that, though, which is important to think about, is one should always consider. One should always consider. I'll just try. Pardon me. Sorry. Let's go back to mouse. Get rid of that. Back to that. Let's go to here. One should always consider, and this is a very illustrative diagram of this, the source of things, the cause of things. So what's the cause of the silt? Well, the cause of the silt is obviously the road surface, so that's one thing. Now, I have built roads which are only being used by quad bikes and livestock that are completely grassed. So we've grassed this whole road area because the frequency of use of that road is we might use it 5-10 times a year or more, not that frequent, and it's got the kind of traffic on it which is not going to undermine us having a permanently grassed surface. And so that's an example to a degree of what's happened here, although it seemed there's actually another road on the other side that we did completely grass, and that's worked quite well. This is the other thing that hasn't occurred really well in here was I gave a direction after this road was constructed to flatten out that batter there. So that's about a 45-degree slope right there. Now, even though this is a non-brittle landscape, we've still not been able to get vegetation to grow on that 45-degree slope. Everywhere will have a limit, but generally in most landscapes that I've witnessed, once you get over 45 degrees of slope, it's quite of cut slope, that is. So where you come in with some sort of blade and remove the topsoil and then just leave that exposed. In most cases, what I've seen is that you will not get any growth, or very little growth will come back on that. So what you have to do, therefore, is drop that slope back. And that's what you can see here. Now, I don't know what happened here because it certainly wasn't the earth mover that came back and did this. The earth mover that did this was one of those, I didn't organise him. He came in, did his job, and then left. Now, he didn't finish the job. He didn't come and do all of the stuff that I'd suggested that he do, like carry on that drainage to the back of the dam, and like drop this batter so that it was, more on a, 25 degree slope, a 1 to 2 or a 1 to 1.5 sort of slope, not a 1 to 1 slope, which a 45 degree is. Now, one can see that as a result of whatever happening there, that right here where the slope is closer to 1 to 2, 1 to 1.5, that grass has completely covered that slope and it's come up to the edge to the shoulder of the road track itself. Now that to me, right there, is the ideal. Now, when we come back to causes and worrying about silt, etc., if you do that, then you will have very little silt make its way, or make it all the way to the end there, because it'll actually be trapped in the road gutter itself. Now, will that cause a road maintenance issue over time? Yes, of course it will, because gradually that siltation will need to be cleaned out. But it's a damn sight easier to go along here with a blade, and a lot cheaper to go along here with a blade on a grader and deepen that and then put that topsoil back than it is to go and to empty a dam of its silt, right? Or it's a lot easier. So that's a trade-off that one will look at. But I've personally not come to the point yet where any of the roads that we've built like this, which we're getting up to 20 years now of building roads, where we've actually had to come and do that clean out yet. So that says something. Yeah. All right. So these are examples of more of these roads at Taranaki Farm that Ben Falloon built. Now, Ben Falloon, in this case, he went ahead after I'd guided him early on a whole lot of this stuff. He went along and did a whole lot of extra roads on his property. Now, personally, some of the road placement that he put in, I think, is a bit superfluous. I don't see the purpose in having these two roads so closely together, for example, but that's his decision. I do always applaud anyone having a bit of a crack. What I did want to show, though, is here's the water running in that gutter, but you get to here and see how the road is not being, he's used the same gradient, but what he's got to is here, and he's got water coming in from the valley above, and so it's running across here. Now, so what do you do about that? Well, this is where you're either going to need to build a dam or you're going to need to put a pipe. Probably, given that that's a lock pipe to a dam right above us here. So what we're looking at, this position here, is right here. So you can see we've got a dam here, there's a lock pipe, and there's water undermining this position right here as a result. And so for this position, like I said, I don't really see the purpose of this particular road, but notwithstanding, if you've got this situation and there's no capacity, or it's just not feasible to build a crossing dam in this case, then that's where you build a culvert in order to be able to get rid of this water. Now, this water is actually running in this direction because he's got a dam which you can't see, which this is actually feeding out on the point of this ridge. So anyway, just all examples you can see here. Now, that's that same road again when it was being built, looking in the opposite direction. Now, again, this is just a straight cut into there. And then you can see there, you've got about what's that? Probably about a 1-to-1 batter there, and the topsoil's been put back on, but there's no gutter. And because there's no gutter, that water will sit in there as it does, as you can see it does here. And you're really playing a bit of a gamble as far as this actually water coming back up the road. And when it does that, of course, it then starts to cut, but it also gets into the wheel ruts and it makes it soft, and you go and drive along it when it gets soft. And so you can see where I'm getting to. It creates a maintenance issue, which is of concern. Bear with me. I've got some. Okay. Now, a couple of questions there that I didn't see. Should I try and keep that grass short? That's an excellent question. Thank you to Ray and Samantha. What we find is, and our place is a really good example of this and others. I'll go to this next. Now, if I go along here, I've cut in. So really this particular road probably got a little bit of fill once we get out to here, but this is all cut, right? So you can see the landscape here used to come along more or less here, right? And so this is being cut in here and then goes up there. So it's really, probably about here is the fill line. So there really is no fill. It's just been a straight cut, unless that's what this is. I wasn't involved in this. I've only got the photos. Now, because of that, when you run a blade over ground, if there's any moisture, it basically glazes the surface. And any of you will have witnessed this if you've used a shovel on wet ground, or if you've seen a blade being dragged over a ground or pushed through ground, that you'll get a degree of glazing. Now, as a result of that, glazing is a form of compaction. And so even if I cover a little bit of that over with topsoil, even if I cover that over with topsoil there, and which is what we recommend you do, if I cover it over with 1 centimetre of topsoil, or 1/2 inch or 1 inch of topsoil, those roots are going to come down and they're going to hit this compacted layer of glazed material. And it's compacted anyway because we've run over it backwards and forwards with the grader or whatever other machinery that we're driving as we construct the thing. And so one finds that what one finds then is that you get this compacted layer, and that the grass naturally typically grows quite short. Now, that's not exclusively the case, but it is usually the case that the grass, because of the limited root zone potential, the grasses are kept at a clip. Now, what also happens, of course, is that, and this may well in your area where you are raised, that you might get more clumping summer active perennials that'll persist in there, and so therefore you might find yourself either having to graze that, and sheep are the preferred grazing animal for this because they just don't have the weight to pug that out, or run along and mow it. That's if you want to have it so that, because if you're in a higher rainfall or a summer rainfall area, you may, well, and any area for that matter, but you may find that because you've created a zone of moisture, periodic but yet reliable moisture, that you might get successional processes which actually have woody plants emerge there, or rushes and reeds and all of those sorts of things. That's why I find it's really instructive to go and look at roads that have been built around you with gutters and reverse engineer a couple of factors there. One is to look at what's the maintenance that's being performed in them. B, looking at the gradient that they have and looking at the maintenance schedule that follows that gradient, because you might find that there is a particular gradient in your landscape where the frequency and volume of water is sufficient on that gradient to self-clean it. And what I mean by self-clean it is that if you have a gradient that's sufficient from this whole discussion, the sufficient gradient is one that is going to effectively harvest water and direct it to your dam. Now, if we look at, this is an example, go away from here. If you look at this dam here, this particular drain here, I might also surmise that the gradient of this is not sufficient, at least at this spot, to actually have the capacity to handle this water as well as the water that runs along this itself. Now, that being the case, would it not have been better for this particular gradient to be steeper, so that if you had water come from here and it hit here, then it would run off quicker and therefore carry that water faster to its destination? Now, the tension with this is how steep before you get to a point where you get erosion in the gutter itself. You know, so that's a bit of a dance, and that's why I'm inviting you, if you're looking to build new roads into your landscape, have a look at some of those that are already on your property. Hopefully you've got some gutters that will be able to inform you about what vegetation succession may occur, if any, as a result of that slope and the amount of water that's flowing down. I know there are a few questions, but I don't know of any other way of looking at the situation locally and finding out ahead of time what the absolute ideal will be, because you may well, Ray and Samantha, being on granite soil, and I think I talked to you about this one when I was at your property, you might look at doing a 1 to 100 to 1 to 200 sort of slope as opposed to a 300 or 400, because granites tend to take up a lot of moisture before they run off. And that being the case, if you were to build a gutter at 1 in 300, it's very unlikely it would perform that well. It would be as a water harvester, because water would just keep infiltrating. So you go a little bit more aggressive on the slope in order for it to actually do its job. But how aggressive is the question? And so that's where you need to look around. But you are definitely going to be a bit more aggressive than what we see here. I hope that helps. Are there any other purposes for the trees along access apart from aesthetic ones? Well, aesthetics are implicit, I suppose, in something like that. But no, the main purpose of that particular shelter belt was it was a shelter belt. Now, the other part of it was that we selected trees which were all purposed to be and proposed to be managed for timber production. So there was another element of that, and that goes right back to what Yeomans was suggesting with the city forest when he came up with that whole concept as well. That the contour strip forest, that farms need wood. He was mainly thinking about it from posts and poles perspective, but some of you have been looking at what Rowan Reed's been talking about. I mean, some of these contour strip forests that I've built over time are, there's a few thousand trees in there, and if they're well managed, then over the journey, then they can, like a lot of forest systems, can be a backbone of yield to your bottom line. If you look at, there was a Regrarians Live that I did with Andrew Stewart and his family and Rowan Reed last year, and Andrew pointed out that how much timber production, tonnes per year, he was getting, as well as sheep yields and honey yields, etc., per year from those systems. So yeah, you can just go and put the trees in and just look at them, absolutely. But we typically would recommend that if people are going to go to the effort and expense of investing in tree systems, that they do it with some other purpose of yield in mind. Now, that may just be that you might put a seed orchard in, you might put in you might just use it for honey forage or for bee forage or that sort of thing. You may just have a system which is quite narrow, and you might just put a couple of fodder trees on either side, or you may not have anything at all. Or you might put in a multi-row system, which is what I would call the timber belt, which is where you're actually getting some timber yields out of it as well. Any erosion rate? Yeah, thanks, Jason. Pardon me, that was Jemmy. Yeah, any erosion reasons you might plant trees along access? Yeah, look, yes and no. Look, trees don't, I'm not a big advocate for putting trees in to solve erosion issues. You get better erosion control. You get better erosion control by actually putting in grassland, perennial grasses, than you do from putting in trees, because often, particularly with eucalypts, you don't have a lot of ground cover under a eucalypt. They let through an inordinate amount of sunlight, and the leaves blow away and so on. And so you often under eucalypts, you'll get a lot of bare ground. So that's not a very good erosion strategy. So yeah, thank you. Good call. Yeah. All right, let's continue on. There we go. So this is the property that we're selling this year. A couple of people are on the workplace now who are going to buy it, which is very exciting. I'm just going through the motions now. So this is an example here of a site that is very much, well, where the where access is a really dominant, and this is what you'll find with a lot of sites, you know, different layers will dominate the design in different ways. And in this case, access is a very dominant feature. So with this particular site, I wanted to build an additional dam, and I wanted to build, so the things that we wanted to do were that we wanted to build another dam, and we wanted to build a house site. So we wanted to build a house site which had good solar access, a good view over the property, you know, the usual parameters that people have, but also position it so that in the landscape, it was its roof apex was 10 meters lower than the highest position on the property. And so with this particular site, when I positioned this, the building site, to a degree, well, not to a degree, the ultimate height of the building site was dictated by the height of the header tank up in this top corner up here, which you can't see in this diagram. So that header tank is 10 meters higher than the proposed apex of the roof here. Why the apex of the roof? Well, because were we to build a house on here, even though we have a low bell rating, that's a bushfire attack level rating. I think it's 12.5. It's been upgraded with the new assessment parameters. So it was bell low, now it's 12.5, which is the lowest of the rankings above low. That we were looking at putting roof sprinklers on to demonstrate to people that this is a way of, an additional way of protecting one's house. I would still probably recommend to the new owners that they do this when they build, because it's there as a parameter. Notwithstanding, they will get mains pressure, that is town pressure water supply into their house as a result of that positioning, right? Which we've talked about before. So once I determined that height, then that determined the height of the road, because the road had to feed into the house, right? But then there was additional water layer consideration of, well, we had an existing dam. And so looking at the design, I was thinking, right, well, how do I connect this dam so it comes out and feeds this new ridge dam, and so on. So what we did was we built this in-slope road, considering that there were also roads around the perimeter. So there's a bitumen or asphalt road which runs along here. It goes for about 700 meters up this slope. So this is the lowest point here on the road, and there's a high point here. So it runs around here, down here, and the gutter, and it runs in. So what we did is we invited that water in, and it runs along this slope here, and then comes to a pipe here, and then goes into here, then runs along a little level drain here, just a box drain, and then runs into here. Now, going back to your point before, I think it was it Ben or somebody else before in the Q&A, yeah, we have run water in here. I don't have much choice in this particular case, and it's proved to not be a big problem. There's a little bit of erosion that's come through here. That's been solved by rushes, and the same here. Rushes have grown really well in here, and so we don't have a big issue with that anymore, because of the environmental response by these plantings, these self-established plantings. Juncus have established and stabilised the situation. So what we also have, this being the highest point over here, we've got a road gutter which goes along here. This is just a gravel road. We capture one side of its gutter. It's a crowned road, so it has a central camber in the middle. So there's a gutter on this side, which we don't catch, and there's a gutter on this side, which we do. We have to keep that open. So I have to go out there every time this road gets graded. For whatever reason, the grader operators don't carry just don't clean that out. So the gutter continues on here. When this gets formalised as a property, there will be a culvert here and a culvert here. And so that will force that water because into here, because we'll put a box drain here. We'll do a little bit of work, which will get that going. Anyway, water runs along here and then goes under that gutter and goes into here. Then we've got the build site. Now, building sites as well harvest a lot of water. Even when this is grassed and got a building house, a building on it and so on, water will still come off it. And so you need to consider that. So we've got that running on. And that's one of the reasons why the water in this, because this is a big bald pot of clay, plate of clay, it runs down and runs off, it's got a slight slope backwards, gets caught in this gutter, takes its sediment and keeps this dam a little bit sedimenty. Not too bad, but that's gives it that colour. The other thing we wanted to do was blend in some existing features. So we've got, I think there's about 40 odd hectares or so. We've got our neighbours' roads which fall into this bitumen road and so on. So we've got all of this water that comes to this point right here. And it's a floodway. It's got a flood marker on it. Water runs into that and then goes into there. Now, my positioning of this dam and its height was also determined by this dam. So this dam here is slightly just, I think it's like 30 centimetres or something higher than this dam here. And so it runs along and then goes along to here. Once it gets to this point right here, it's level. Whoops, go back to here. It's dead level right here. And from there to there, it's level. So what happens then is the water, as it pushes through here, it continues to run along level, because that's what happens. Even though it's level, because the water's pushing from where it isn't level, it will continue to push through until it gets to this dam. Now we only just finished this feature in the last month. For a variety of reasons, but this has been just been done, and so and we got. I don't have a rain gauge out there now, but we got about 30 or 40 millimeters, and that caused this dam to fill up. It was nearly empty. There was I had about 1.5 meters of water left in it, and this one here had about 2 meters of water left in it. So basically, it filled this one up to within about 2 inches of overflowing, and we're really looking forward to that, because what we've got here is a 10-metre wide spillway that so what will happen now is water will overflow from here. It will then, if these two dams both fill up, then the water will back flood through this level channel here, and then it will come to where the two waters meet. And then what we've done here is we've removed the embankment. There's an embankment that runs along parallel with this. We've removed the embankment there, so it will just find its way out through a 10-metre wide spillway, which is about the width of this stream bed anyway. So we're confident that will take the water that we need to. Now, question here from Ben. The water turning 90 degrees from the road gutter and heading into the property. Yep, these ones here, yep. How do you best manage peak flows around tight corners? Excellent question. I might have to address that during the week, because I don't know that I've got some photos in this diagram. No, I haven't got any photos in this particular slideshow of that, but I do have some photos of these situations. One of the best things, to start with, it's not a 90 degrees. It's actually more of a sweep. So I've got it in as much of a sweep as I can. This one is probably a bit tighter. It's a bit more like a 90 degree, but it's not quite. But what we've done is we've created a curve. You create the curve and you create the width in the base, and it will tend to be able to take a fair bit of water. The other thing I would say too, Ben, is that we're not carrying a huge amount of water down along here. But we do get pulses, like we've had up to 75 millimetres in 20 minutes, so 3 inches in 20 minutes as a peak flow. And both of these corners have been able to take that. So we have had a bit of retrospect, we've had the evidence to sort of prove to us that the treatment is working. But yeah, just try and keep as much of a smooth curve as you can on that. And so I actually excavated that a bit and created a nice batter and tried to keep the base of it nice and flat before it went on its new direction, if that makes sense. But yeah, I've got some photos of those scenarios which might help. So that's the scenario a bit later, when things have settled down, and you can see here there's the, just in the context of the greater landscape, there's the road coming down, some of our neighbours' driveways and whatnot, but there's that tank up in the corner and so on. But that's all worked quite well. Now, another person of interest in all of this, one person who's written a really good piece is Bill Z. Dyke. And Bill wrote this as a free publication, and it's there should be a reference to this already in the Access page of the Regrarians Workplace. It's one of the references for this topic, for your task work. Water harvesting from low standard rural roads. It's a really good piece, and like I said, it's one of the very few pieces that have been written. And it talks about, what different types of road cross sections there are. Like we mentioned before, the outslope road in one of the questions, and then we spent a fair bit of time this morning talking about inslope roads where we're actually harvesting water off that and so on. So there's quite a few different types of roads. The main roads that we build are crowned roads, inslope roads, and outslope roads. If I do an elevated road, it will still always have a crown on it because that kind of road doesn't control water. Controlling water is really, really important. Now, one of the concepts that they came up with in this piece, which I thought was brilliant and still do, is what's called a rolling dip. Now, a lot of you will come across scenarios where, you're driving down a slope, or you've got scenarios where you've got a slope on the road, and a lot of people will put what I call speed humps in France. They call them a gendarme couché, which translates roughly to a fat policeman lying on the road, which says something about the French, although some French. There's other parameters to this which, I'll go back. Now, those speed humps, or where people do that, they're really problematic. A lot of people, they're not good for the suspension of your vehicles, for a start, because they're often quite abrupt. I think that they're quite dangerous, particularly when you're towing on slopes. And if you're going down a slope and it's wet, then you've got to slow down. Well, what happens when you slow down when it's wet? Well, of course, you lose traction. And if you've got a big weight behind you, then that can be quite dangerous, as I've found myself. I used to have a Land Rover, it was a Discovery, and it had traction control. And I remember driving, I had a load of wood that I was on a fairly greasy farm track, and it was probably about a 15-degree slope or so. Anyway, I was driving down it, and it was quite greasy, and I had to come to a stop for one of these that had been built into the farm track, and I lost traction completely. And it actually was, I pressed the hill descent button, which I had, in order to be able to get down it past that, because I'd lost so much traction that the trailer was close to jackknifing, as I'm coming down and my front wheels started to skew. Well, then what happens to the trailer behind? Well, it doesn't care, and so you get this situation where the two curve at each other on the apex of the tow ball, and so that's put the wind up me a bit. So for the rest of that slope, I had to use the traction control, which is really high tech. I don't have a car with traction control now, but what it does is it controls the anti-locking braking system to basically use the brakes to allow traction through each wheel. So you basically walk the vehicle down by each wheel and the brakes. Not the ideal, right? The better scenario would be for that road to have had a rolling dip. So we would have been able to just have the vehicle, which is what I had it in low range, and just basically idling down with little dabs on the brakes, just to keep the thing going very, use the engine braking to go down, and and then not have these stops where you physically need to stop, because if you don't, you tear your front end out of your vehicle, and so on. So, and plus you've got to go over it gently, because when you go, because they're often so abrupt, they haven't actually considered tow hitches and all of that sort of thing. And as the tow hitch goes over, it can bottom out, and so on and so forth. So there's all of those sorts of things to consider. Now, the corollary of this whole thing as well, and this happens especially when you're going up that slope, what happens when you come up to one of these? Well, when you're going down, you typically will lose traction, but when you come up to one, you slow down and then you go over it. Now, if it's greasy, or even if it's not, and you're towing a weight, you'll lose traction. So, of course, as you lose traction, you create wheel marks and you create ruts. And what happens with water then? Water goes nicely down the ruts, and you've just created a nice little erosion channel. And that's what happens. So how do we remedy that? Well, this is one of the remedies, and these rolling dips, and that sort of shows you in real life what they look like. Now, I looked at this design and I started to build them, and I thought, oh, yeah, right, okay, this is interesting. And then as I looked at the different ways that people have built them. And so the premise is that you cut dirt from here and a bit out here in order to get the ditch, get the water to move as it flows down at this sort of 30-degree angle here, or 60-degree angle, and on a 1 to 6% slope, and then have it run across like so. And it's falling out across here. And then the dirt that you dig from this little ditch here and from this ditch here goes up onto here. Now, I looked at that. I looked at this area, because if you go back to this cross section, you'll notice that if that's the road height, what we've done is we've actually created a little depression. And I looked at that from a maintenance perspective, and I witnessed it from a maintenance perspective. I went, okay, well, that's a little spot where silt's going to trap and blah, blah, blah. And how do we get it so that we get a bit more control of water? And that, because the other thing that happens, if you don't have sufficient fall through here, is that you can get a lip of vegetation form here, and then that creates a little dam, and then you get a pondage behind you here. So we came up, and it wasn't until I went to Queensland and I went to this property, Kylie Stratton's place near Charters Towers, and I looked at this property and I went, oh, right. So this other person, I can't think of their name now, but they do a bit of road work in the Territory, and in the Northern Territory in Queensland, in a lot of the dry land station country up there. And they'd come up with a variation on the rolling dip. And this is it here. And so what they'd done is they'd excavated this pond here quite crudely, and the dirt that came from this pond was placed on this embankment here. And so, I need another photo here, which I do have, not in this presentation, but so water runs down this slope and then meets this quite gentle speed hump, and then runs across and then fills in this pondage and then runs off. So that's how it actually runs the other way. So it runs down this way, goes across to here, fills this up, and then overflows, right? Now, I looked at that and went, well, that's very interesting, because what didn't happen here was that the road itself was not the source, and that of the material for the embankment, and the water the water ran across this much better. So I looked at that, and when we did Megan Giroux' design or concept and design for her particular property, Georgie and I said to Georgie, yeah, let's combine some of these concepts and build it. So we did in CAD. So here we've got a road. So these are gradient roads. There's no need for them because there's no need for a speed hump. But here we've got a ridge road, right? So we're running down this ridge, and so I said, all right, well, so Georgie did the calculations on the volume of flow that was going to come. And what we did, I said to Georgie, okay, let's calculate, because there's no rules on this that we were able to find. Let's have as a parameter for determining the positioning of these. So you can see there's one here and there's another one you can just see to start off here. Let's position these based on peak flow volume and the catch and the capacity of one of these little ponds that we'll build. So we looked at it and went, okay, well, and so Georgie did some parameters and he worked out the peak flow volume over the whole road length. And then I said, well, how about we put in 3 and let's see what that looked like. We built the 3 and then we looked at what that was going to cost and how much excavation. And we went, okay, yeah, 3 looks about right for how many we need to run down here. And so that's what we ended up with. And I don't have the figures in front of me, but this here is probably about 15 metres, 10 or 15 metres long and about 2 or 3 metres across. So it's quite a small excavation. And unlike this one here, which is quite crude, as you can see, they've just come in with a backhoe and they've done that really crude. My spec on this was that this would be topsoiled, it would be to a depth. It's silting up pretty readily, this one, and so on. I'd made it bigger so that it actually became a feature, a water harvesting feature in the landscape, and so on. So there were all of those factors which we considered in the design of this particular one here. And there's a bit of an embankment there. So that's how that came about. And you can see that in a bit more detail there. That's another variation on that. So, oh yeah, no, don't worry about that. Now, this is the last slide I have in the sequence this morning before we go to further questions. This is another system. This is called a French drain. This is one that my good late friend Joe Palosha built. This is a couple of bits of 2x6 or 6x2, 6 inches by 2 inch wood, just rough sawn cypress in this case. Joe has fashioned out of one of his favourite materials, old car leaf springs or vehicle leaf springs. He's cut them down to make a really, really cool, strong spacer, which he's put some nice clouts into, both inside and on the outside. And you can sort of follow. So that's a flat piece of steel. He's cut along, bent it, put a bit of heat on it, bent it over, and then put a clout in there and a clout in there. That keeps it spaced. Then he used another leaf spring, which he put onto a handle, which he then used to clean the gravel out of this, which he just tossed back up on top there. So what Joe had here was a series of these running down a very significant slope to his property. Now, put this in context, this property, where it is in New Zealand, receives 2,000 millimetres of rainfall on soils which are about 45% clay, and they're non-reactive clay. It's a very famous area for its pottery. So it's got this really, really stable kaolinic clay. So the outcome of that is really high levels of runoff in a high rainfall area. So, and his road in most of its journey is 30 degrees of slope. So it's a really steep road, and he was able to manage it entirely as a gravel road by having a really nice camber on it the whole way down. So he was able to minimise the amount of runoff that was going down parallel with the roads itself, and intercepted anything that ran off and switched it back from gutter to gutter by having these French drains and maintaining a strong maintenance program. Now, he did that quite well, and it worked extremely well. I drove up and down that road many, many times, and it was fantastic even after he died. But a road that needs maintenance. So I suppose the discussion on this one is, what do you do? How much are you prepared to put in on maintenance, or how much are you prepared to put, or how much are you prepared to put in capital? So, if we're going to have a road that doesn't need as high a frequency of these and is able to maintain traction better, then you really need to think about sealing it and with a proper seal. And then you get your traction. And like I said before, there's going to be some cases where that's going to be mandated for you to do that anyway because of access to emergency vehicles, which in some jurisdictions are required. Okay. Well, I've got to the end of that section. What I would like for you to do is, from a task work point of view, and I'll repeat this I'll put this over in the workplace as well, is have a look at all of the existing roads that you've got, and following up on the point that I made with Ray and Samantha earlier, is go and have a look at roads around you and sort of reverse engineer, get a bit of a sense of what are going to be the ideal drain proportions or dimensions, what are going to be the ideal drainage slopes or gradients that you choose. Look at inslope, outslope. You may not need to harvest water, so look at the possibility of doing outslope roads as well, where the road surface slopes away, and so that it's got a sufficient slope where it's safe, but that water will just run again perpendicular to contour across that road and go into the landscape, thereby reducing the need to have any culverts, that sort of thing. But you're still going to have to look at that. That's one of those things. What sort of condition the roads are in, and so on, and what sort of work you might need to do, what existing culverts and drains, and then looking at because we're always looking at existing and then proposed. So analyse the opportunities for enhancement and development. And then in Google Earth Pro, you get a chance, look at your access layer and develop a concept plan around that, and annotate them so that you can refer to them, and share the whole access folder when you're done. Now, the primary reference is water harvesting from low standard rural roads. When we get to the point where we've finished the access chapter, and that will be the standard reference, and it will include reference to the Zadike book. All right, now a quick question from Ben regarding the GE layers. I'll just get out of here. Do I have anything else? That was it. Yeah, that's it. Just escape. Time, we're just over time. Good. Quick question regarding GE layers. My farm plan is getting busy. How do I best share those layers that are relevant, or yeah, that's a great question. One of the reasons, and I haven't seen your setup, Ben, I don't think, or if I have, please let me know. But one of the best things that you can do in Google Earth, and sorry, I'm not on my home computer here, so I don't actually know if I've even got Google Earth on here, have I? No, I don't think I have. But go into Google, I'll get it on today, but go into Google Earth, and now if you've used our template, our folder template, then all you should have to do to share, say, the access folder, for example, is right-click on so select the access folder, right-click on it, and then share that particular KMZ, all right, or KMZ. If you select the whole folder, if you select them all, like you go right up to the top of the tree, well then of course you'll share the whole lot. So just turning layers off and on won't actually stop them from being shared. You've got to you share things at the individual file level or the individual folder level, but you've got to be careful. That's why we set it up the way we have. You've got to be careful that the folders that you haven't corrupted that folder integrity or setup. Otherwise, you will find yourself sharing everything that's included in that folder. or folders. All right. I don't know if that makes sense. It's a bit hard for me to demonstrate. I'll just double check it's not on here because it may be. Oh yeah, there it is. Sorry, pardon me, it is on there. Yeah, that makes sense. Good. All right. Oh, God, I can't remember any of that. Okay, here we go. Now I don't know. So what's even on here? I don't think there's any data on this computer. I'll just show you just so that we're clear for everyone else as well. So I bought my little portable hard drive, geography. GIS data, Google Earth. So the Regrarians platform GE template, that's the one I've recommended to you. So that'll just open up. Now, if that's what you've used as your template, Ben, just to round this off, and you save place as and then share that with me, then everything that's in there will be shared. Now, let's say though, for example, that you just want to share the water folder, well then you'll just select the water folder, because you can see how in the architecture of this, see we get those arrows? That means that they're within the broader, they're within this meta folder, but each one of these is actually its own layer, if you will, and that's the way I've tried to set it up. So if you're just selecting, let's say we go to Access, and you've done all of your work on Access, and let's say that you've got, let's make this a bit wider, pardon me. You want to show us all of your existing roads. Well, then you will select that. If that's what you've got to start with, you'll save place as, and then you'll share that with me. But if you've got a proposed layer, then you'll do that. Otherwise, you just select just the access layer and do that. Yeah, I'm sure that makes better sense than my description. All right, but that's how you do it. And again, that's why I set it up this way, so that, you know, it made it easy. Well, it worked both ways. It made it easier for me, and it made it easier for you. Okie doke. All right. Well, thank you so much to you all for joining us today, and really great to be back. I've had a wonderful time with my family over the Christmas New Year break of a month, and I'm really pleased that it's an expression of our holistic context, which we shared with you earlier in the year, last year. Actually coming into play and being planned for and all of that sort of thing. And I feel quite renewed. I've had a really great time with my friends, and particularly with my family, and looking forward to a pretty big year ahead, some of which has been started already by our call for funding for the Regrarians Handbook, which we're about 20% into, we've got about 20%, which is great, because we'll be able to do about the next few chapters. We'll continue to fundraise, and I'm sure that there's a few things that'll happen. I'll put my own capital into it as we get some from property sales this year, and from continuing to save from the Regrarians Workplace and subscriptions. But also, I'm sure that as we produce more chapters, then people go, yeah, these people are serious and on track, and we'll get some more cash that way. But yeah. Very, very much looking forward to the year, looking forward to getting out and doing some Rexes overseas this year, so keep an eye out for that. I haven't planned anything completely yet, but that's going to happen. I tried to do as little work as possible over the Christmas New Year break, and was pretty successful in doing so, and probably need to go for quite a few runs as a result. Yeah, got a lot of planning to do over the next month, and we'll let you know as we do. All right, well, thank you very much, and look forward to your task work coming in. If it's not from this week's work, well, then from previous weeks, and just remember to tag me when you post something in the workplace. With that, thank you very much, and All the very best to you all.